Good evening everyone, good evening. I welcome you all again to NEET Elite. I hope all of you are doing wonderful. Yeah. So people, quickly let me know in the chats if I'm perfectly audible and visible to everyone. Hello Yuashri, hello Ashwarya, hi Ishpreet, hello Hitesh, hello Hafsa, walaikum salam, hello Rashda, walaikum salam, hello Ishpreet. Hello Harsh, welcome back everyone, welcome back. Hello Arjit. Just let me know quickly, my dear people, if I'm perfectly audible and visible to everyone, yeah? Give me some green signal from the chats. Hi Divya, hi Roshni. Welcome back. Hello Deena. Welcome back all my elites. Just give me some green signal, people, from the chats, so that I'll get to know that I'm perfectly audible and visible to everyone. Yeah? I'm doing good, Ishpreet, thank you. I'm doing good. Harsh, thank you. So people, it's going to be our second session for IUPAC Nomenclature, right? In the last session, if you remember, we did the naming of some compounds, right? By following certain rules, right? What all things we are going to cover in the tonight's session? Well, in the tonight's session, we'll be seeing exactly how to write the names of the Bicyclo compounds, right? Then we'll see exactly how to write the names of the compounds wherein different functional groups are attached, right? All those things we are going to cover in detail in the tonight's session, right? So before starting the session, the ones who have just joined in, the ones who are new to the channel, let me quickly introduce myself. Well, people, my name is Wassim Sir, and I'm your chemistry master teacher right here on this particular NEET Elite channel, right? The ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this NEET Elite channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well. Let everyone get benefited out of these sessions, okay? So you guys can first of all let me know in the chats if all of you are super duper excited about the tonight's session, my dear people. Yes? Let me know fast in the chats if all of you are super duper excited about the tonight's session. Let me see the Josh of the session first. Let me know fast in the chats. Let me know fast in the chats, my dear elites. Yeah? That's wonderful. That's great. Okay, so people, before starting the session, let me tell you, few minutes back, I just uploaded one video on this particular channel. I hope you guys have seen that, right? And what is that video all about basically? Vedantu is coming up with something big for all of you. For the ones who are going to write the NEET in 2022 as well as in 2023, right? We are coming up with something really amazing for all of you, which is going to ease out your preparation for the NEET 2022 and 2023. Well, tomorrow at 8 p.m. sharp, I will be revealing that surprise exactly, right? Okay, so till then, you need to stay tuned to the channel, right? I would want you guys to watch that video, which I just posted like half an hour back on this particular channel only, okay? So it's going to be a surprise, which I'll be revealing tomorrow at 8 p.m. sharp, okay? All right, before starting the session, can you just let me know how many of you watched the first session of IUPAC Nomenclature, which I took few days back? Just let me know quickly in the chats how many of you actually watched the first lecture of IUPAC Nomenclature. Just let me know fast in the chats, my dear people. Just let me know fast, yeah? You can honestly tell me. Perfect. That's great. That's wonderful. Okay, one more thing I would like to tell you before starting. I thought this IUPAC Nomenclature is going to end in 2 sessions, but it's going to take 3 sessions basically, okay? So apart from this particular session, which I'm going to take tonight on IUPAC Nomenclature, I will be taking one more session, right? And in that 3rd session, your whole IUPAC Nomenclature is going to get covered, right? Okay, so one extra session I have added for IUPAC Nomenclature, okay? Perfect. All right, so let's get going then. Let's get started with the tonight's discussion and let's get to know how to write the names of bicyclo compounds, right? How to write the names of bicyclo compounds. The common example of the bicyclo compound over here on the screen, right? What are bicyclo compounds basically? Bicyclo compounds, they consist of two fused rings. These are two rings which are fused basically, right? Or I can in short tell you bicyclo compounds, they have got two carbon atoms in common. Your spiro compounds, they had one carbon atom in common, right? And in bicyclo compounds, there will be two carbon atoms in common between two rings, right? As you can see, this carbon atom and this carbon atom, it is common to this ring as well as this particular ring, right? Whenever you find such kind of compound wherein there will be two common carbon atoms between two rings, you call this particular compound as the bicyclo compound, right? Number one. Number two, these two carbon atoms which are common to both the rings, we call these two carbon atoms as bridged carbons, right? We call these two carbon atoms, this one and this one in particular, we call them as the bridged carbon atoms which are common to both the rings, okay? So we are going to see exactly how to write the IUPAC name for the bicyclo compounds over here, right? Let's have a look. Let's have a look. This is the structure which you are going to follow. Before writing the word root, you will be writing bicyclo. And in the bracket, there will be three numbers. In the bracket, there will be three numbers, X, Y, Z. What this X is, what this Y is, what this Z is, that's something which I'll be telling you in some time. Before word root, the way you used to write the spiro compounds, before word root, you used to write spiro, right? In the similar way, in case of bicyclic compounds, before word root, you'll be adding bicyclo. Then you'll be writing three numbers, X, Y, and Z, right? X, Y, and Z. What are these numbers exactly? That's something which you'll get to know in some time. And before this bicyclo, there comes the prefix. After this word root, primary suffix, then the secondary suffix, right? Let's understand one by one what all things we are going to talk about now, okay? Have a look, people. I will be taking one common example, right? This is one common example. Let me quickly show you how to write the name of the bicyclo compound, okay? Right? Have a look, guys. Have a look what I'll be doing exactly. First of all, if you look at this particular compound, the first thing I have identified, there are two common carbon atoms between two rings. These are the two common carbon atoms, right? And in any compound wherein you find two carbon atoms in common between two rings, you call it as the bicyclo compound, right? So first thing, I will be writing bicyclo over here. I will be writing bicyclo over here. The first thing which I've written, correct? Number one. Number two. Over here you have got two rings. This is one ring and this is one more ring, right? We have got two rings, okay? So first thing, people, understand. In spiro compounds, we used to start numbering from smaller ring, right? We used to start the numbering from smaller ring. And over here in bicyclo compounds, we will be starting the numbering from that ring which contains more carbon atoms. Which ring among the two contains more carbon atoms? This ring actually contains more carbon atoms, right? So I will be, first of all, while numbering the particular compound, I will be giving priority to that ring which contains more carbon atoms. And I will be always starting the numbering from the bridged carbon, either from this or from this, okay? So the first priority has to be given to that ring which contains more carbon atoms. So this ring contains more carbon atoms, so I'll be giving priority to this particular ring, right? And I'll start the numbering from the bridged carbon. Let's call this as carbon number 1. Let's call this as carbon number 2. Let's call this as 3. This is 4. This is 5. This is 6. This is 7. This is 8, right? So this is the way we are going to do the numbering first of all. Number 1. Number 2. If I ask you, in order to move from carbon number 1 to carbon number 6, if you want to move from carbon number 1 to carbon number 6, how many paths actually are available for us to shift from carbon number 1 to carbon number 6? This is one of the path by means of which you can go from carbon number 1 to carbon number 6, right? This is one more path by means of which you can go from carbon number 1 to carbon number 6, and there is one direct path which is the shortest among all, by means of which you can go from carbon number 1 to carbon number 6, right? There are 3 paths available for us by means of which we can move from carbon number 1 to carbon number 6. This is the longest path, this is the shorter path, and this is the shortest path, right? Have a look. After bicyclo, use the bracket. See the number of carbon atoms which are there in the longest part. In the longest path, how many carbon atoms are there except the 2 bridged carbons? 1, 2, 3, 4. So 4 carbon atoms in the longest path. I'll be writing 4 first. Longest, shorter, shortest. See, this is the longest, this is shorter, this is the shortest. First, I'll be starting from the longest path, then go to the shorter path. This is the shorter path. How many carbon atoms are there in the shorter path apart from these 2 carbon atoms? 1 and 2, right? So after 4, I'll be writing 2, right? Now, finally, reach to the shortest path. This is the shortest path. Is there any carbon atom coming in between these 2 carbon atoms, right? There is no carbon atom in between, right? In the shortest path, there is no carbon atom. So I'll be writing 0. I hope you got to know what this X is, what this Y is, what this Z is. What is X? What is X? X means the number of carbon atoms which are there in the longest path, except these 2 bridged carbons. Longest, shorter, shortest. Longest, shorter, shortest. In the shorter path, how many carbon atoms are there except these 2? 1 and 2. So 2 I've written over here. And in the shortest path, there is no carbon atom in between, right? And apart from after that, what I'll be writing? See, how many carbon atoms are there in total? 8. What is the word root given to 8? It's oct. And everywhere there is a single bond. It's going to be ane. So this is going to be the name of the compound. As simple as that, right? So in short, remember, this is the longest, this is shorter, this is shortest. The number of carbon atoms which comes in the longest path, the number of carbon atoms which comes in the shorter path, the number of carbon atoms which comes in the shortest path. That's something which you need to remember. That's all. That's all, my dear people, right? Now, if you look at this particular compound, have a look on this particular compound. Have a look on this particular compound now. See, first of all, do we have the 2 carbon atoms in common? Yes, we have got 2 carbon atoms in common. These are the 2 carbon atoms which are common, right? These are my bridged carbons. I'll be starting the numbering from the bridged carbons, right? This is, for example, carbon number 1, or you can call this as carbon number 1. The choice is all yours, right? This is carbon number 1 first of all, right? Now, people, let's call this carbon number 2. Let's call this as 3. Let's call this as 4. Let's call this as 5. Let's call this as 6. It's not done yet. There are 2 more carbon atoms, this one and this one. 6, let's call this as 7. Let's call this as 8. Perfect. I have given the numbering properly. Now, first of all, are there 2 carbon atoms in common? Yes, there are 2 carbon atoms in common. So, before word root, I will be using bicyclo. Right? I will be using bicyclo. Now, people, have a look. Exactly, if you move from carbon number 1 to carbon number 4, this is one of the paths available for me. If I move from carbon number 1 to carbon number 4, this is one more path available for me. If I want to move from carbon number 1 to carbon number 4, this is one more path available for me, right? Yes. Now this path exactly contains 2 carbon atoms except the bridged ones. This path again contains 2 carbon atoms except the bridged ones. This particular path, it contains 2 carbon atoms except the bridged ones, right? So it's simple. The value of x, y, z everywhere is going to be same, right? The value of x, y, z is going to be 2, 2, 2, right? Right, people? Then how many total carbon atoms do we have? We have got 8 carbon atoms in total. So the word root which I'll be using, it's going to be oct, and everywhere there is a single bond. So this is going to be the name of the compound. I'm sure this is clear to everyone, right? Perfect, people? I'm sure it's clear. Now, if you look at this particular compound, let's try to name this particular compound. First thing. Find the bridged carbons. These are the bridged carbons over here, right? These are the 2 carbons which are common to both the rings, right? Now, I'll be starting the numbering from the bridged carbon. Let me call this as carbon number 1, right? Now, I've got 2 ways to give the numbering, either in this direction or in this direction. And in case of bicyclo compounds, we always prioritize that ring which contains more carbon atoms. So this ring contains more carbon atoms. No doubt, this particular ring is substituted. I've got nothing to do with that. I have to give priority to that ring which contains more carbon atoms. So I'll be giving priority to this particular ring. So let me call this as carbon number 1, this is 2, this is going to be 3, this is going to be 4, 5, 6, 7, and 8, right? Now people, now understand. So before bicyclo, there is a prefix. We need to write the prefix. Do we have to write the prefix over here? Absolutely. Because at carbon number 7 and at carbon number 8, there are 2 methyl groups attached, right? Yeah. So I will be writing something like this. It's going to be 7, 8. 7, 8. Then I'll be writing dimethyl. 7, 8, dimethyl, right? Prefix is dusted, done and dusted. Now, it's a bicyclo ring. Now, I'll be using the term bicyclo. Bicyclo, right? In the brackets, X, Y, and Z, right? See, this is the longest path from carbon number 1 to carbon number 6. This is the shorter one, and this is the shortest one. In the longer path, in the longest path, how many carbon atoms are there? Except these two bridged, 1, 2, 3, 4, right? So value of X is 4. In the shorter path, how many carbon atoms are there? 1 and 2, so 4, 2. In the shortest path, is there any carbon atom? No carbon atom, so 0. Perfect. Now, how many total carbon atoms are there? There are 8 carbon atoms in total, right? For 8, I'll be using the term oct, right? Everywhere there is a single bond, so it's going to be octane. So this is the name of the compound. Let me quickly know in the charts if it is clear to everyone. Yeah? Let me quickly know in the charts if it is clear to everyone, so that I can move on and give few more examples by means of which these bicyclo compounds will be clear to you. Right, people? Yes, Hanishma, I teach in the actual Vedantu platform as well. Absolutely. Perfect, guys. Wonderful. Let's move on. These are few more compounds. Let's try to figure out the names of these compounds, right? So first thing, we need to see whether these compounds are bicyclo or not. Absolutely, all these compounds are bicyclo because you have got 2 bridged carbons, right? You have got 2 carbon atoms which are common to 2 rings, which are common to both the rings. Both the rings are fused together basically, right? Now have a look. Have a look exactly. I will be starting the numbering from this carbon, for example. Let me call this as carbon number 1. Now I've got 2 ways, either to go from this side or to go from this side. This particular ring, it contains 2 carbon atoms. This particular ring, it contains 1, 2, 3 carbon atoms. And you know, we have to select that ring, we have to prioritize that ring which contains more carbon atoms. So this is going to be 2, this is going to be 3, this is going to be 4, this is going to be 5, this is 6, this is 7, and this is 8. I have done the numbering, right? Now first thing, it's a bicyclo compound, so I'll be writing bicyclo over here. Bicyclo I mentioned, right? After bicyclo, the numbers X, Y, Z. X, Y, Z. Have a look. See the longest path by means of which you can move from carbon number 1 to carbon number 5, right? This is the longest path. Which one is the shorter one? This one is the shorter one. Which is the shortest one? This one is the shortest one, right? How many carbon atoms are there in the longest path? 1, 2, and 3, right? It's going to be 3, comma. In the shorter one, 1 and 2, 2 carbon atoms. And in the shortest one, 1 carbon atom over here in the shortest one, right? So I'll be writing 1 over here. Total, how many carbon atoms are there? There are total 8 carbon atoms. So I'll be using the word root oct. Everywhere is single bond, so it's going to be octane. So this is going to be the name of the compound. As simple as that. Right, people? Let me call this is carbon number 1. This is 2, for example. This is 3, and this is 4. Again, this is a bicyclo compound, right? Again, it's a bicyclo compound. 2 carbon atoms are common to 2 rings, right? 2 carbon atoms are common to 2 rings. Yeah? Again, the bicyclo compound. Now understand. Understand properly. I will be using the term bicyclo first of all. Bicyclo. Okay? So it's going to be, see, every path, this path is same, this path is also same, and this is the shortest path, right? So it's going to be over here 1 carbon, over here 1 carbon, it's going to be 1, 1, 0, right? How many total carbon atoms are there? There are 4 carbon atoms, so it's going to be but. Everywhere it's a single bond, so it's going to be butane. As simple as that. Right, people? If you look at this particular one, first thing, what you need to do, you need to find the bridged carbons. These are the bridged carbons. These are the carbon atoms which are common to 2 rings. Yeah? Now after this, I need to do the numbering, right? I'll be starting, for example, from this carbon. Let me call this as carbon number 1, because we always start the numbering from the bridged carbon. either from the top or from here. The choice is all yours. Let me call this as carbon number 1. Now I've got two ways. See, in this particular path, we are getting some 2 carbon atoms. In this particular path, we are getting 2 carbon atoms. So both the paths are same, but over here, there are substituted groups attached, right? So I'll be giving priority to this one. 1, 2, this is 3, this is 4, this is 5, this is 6, and this is going to be 7, this carbon. Yeah? Perfect. So first thing, at 2 and 3, there are methyl groups attached. So it's going to be 2, 3 dimethyl. 2, 3 dimethyl. Then I'll be writing the term bicyclo. This is bicyclo, right? Bicyclo. And then in the brackets, we have to give the numbers. Yeah, we have to give the numbers. See, this path from carbon number 1 to 4, this is one of the path available. From carbon number 1 to carbon number 4, this is one more path available. And this is one more path available, right? So this particular path, apart from the bridged carbons, it contains 2 carbons. Right, this particular path, apart from these 2 bridged carbons, it contains these 2 carbons. So it's going to be 2, 2, 1, right? This shortest path contains 1 carbon in between. So it's going to be 2, 2, 1. Then you have got total 7 carbon atoms. So I'll be using the term hept. And single bond everywhere. So it's going to be A. So this is going to be the name of the compound. I'm sure it's clear to everyone, right? Perfect, people. 2, 2, 1, hept A. Let me take few more cases. These are few more cases. Let's try to understand. Let's try to name all these compounds, all these bicyclo compounds over here. Again, I'm sure you can easily solve them now. See guys, now these are simple. So start from here. This carbon number 1, right? Now over here is a double bond, right? See, first thing, these are the 2 bridged carbons which I've selected. Perfect. From this particular bridged carbon till this particular bridged carbon, how many paths are available? One of the path, second path, and third path, right? This particular path and this particular path contains same number of carbon atoms, 2 and 2, right? But this one contains pi bond as well. So let me prioritize this one. 1, 2, 3. This is 4. This is 5. This is 6. And this is 7, right? So first thing, I will be using the term bicyclo. It's a bicyclo compound, right? Then it's going to be 2, 2, and 1. 2, 2, 1, right? And total carbon atoms, 7. So it's going to be hept. At carbon number 2, there's a double bond. So hept 2ene. This is the name of the compound. As simple as that, right? Right, people? Look at this particular one. Bridged carbons, right? From here, 1, this is 2, this is 3, this is 4, this is 5, this is 6. So what is going to be the name of the compound? It's going to be 2, 3 dimethyl, right? It's going to be 2, 3 dimethyl, yeah? Dimethyl. Then I'll be using the term bicyclo because it's a bicyclo compound, right? So it's going to be 2, 2, 0, right? 2, 2, 0. How many total carbon atoms are there? There are total 6 carbon atoms in the chain, right? So I'll be using the term hex, right? Everywhere there's a single bond, so it's going to be ane, done and dusted. Right, people? Yeah? Perfect. Similarly, have a look on this particular one. Start from this bridged carbon, 1, right? Okay. Now both the rings, they contain the same carbon atoms. Right? And this one is substituted as well. So give priority to this one. This is 2, this is 3, 4, 5, 6, 7, 8, 9. And this is 10, right? Now people, at carbon number 3 and carbon number 4, there are methyl groups attached. So I'll be writing 3, 4 dimethyl. 3, 4 dimethyl, correct? Then it's a bicyclo compound. So I will be writing bicyclo after this. Bicyclo, right? Now over here, 1, 2, 3, 4. It's going to be 4. 1, 2, 3, 4. 4. This one contains 0 carbon atoms in between. So it's going to be 4, 4, 0. Right? 4, 4, 0. Perfect. Now, how many carbon atoms are there in total? 10 carbon atoms. I'll be using the term dec. Right? At carbon number 3, there is a double bond. It's going to be 3. And for the double bond, we use ene. So this is going to be the name of the compound. Perfect, people? I'm sure it's clear to everyone, right? Let me know quickly in the charts if it's clear. Perfecto, guys. I'm sure from now onwards you can give name to any bicyclo compound. I'm sure about that, right? What is the temperature in Kashmir? It's going to be somewhere around 1 or 2 degrees centigrade, something like that. You can check it out in Google, by the way. Okay, people. So let's move on then. Let's move on. Let's try to give name to this particular compound as well. It's again the simpler one. Just select the numbering from the bridged carbon, carbon number 1. Let me call this as 2. Let me call this as 3. Let me call this as 4. This is 5. This is 6. And this one is 7, right? So at 2 and 3, there are 2 methyl groups attached. So it's going to be 2, 3 dimethyl. 2, 3 dimethyl. Then it's a bicyclo compound, right? Then I'll be using bicyclo over here. Bicyclo. Give the numbering. 1, 2, 1, 2. And this is 1. So 2, 2, 1, right? It's going to be 2, 2, 1, right? How many carbon atoms are there in total? There are 7 carbon atoms. I'll be using hept. But people, have a look. We have got 2 double bonds. Whenever in a compound there will be 2 double bonds, I mean there will be multiple double bonds or multiple triple bonds. At that time, if you remember, we use A over here. It's going to be hepta. It's going to be hepta, right? After writing hepta, so at what all positions we have got the double bonds? At carbon number 2 and at carbon number 5. So it's going to be 2, 5, then comes di and ene. This is going to be the name of the compound. Perfect? Perfect, people. Again, a simple compound this was, right? If you just remember the rules, I'm sure you can easily kill them. So let me know in the chats if every single thing is clear till here, so that I can move on and talk about few more interesting things, yeah? Let me know in the chats fast. If everything is clear, I'm looking at your chats only. Hanishma, you need to talk to the operational team about it. They'll let you know exactly how to find my batch on the actual Vedantu platform. Okay? Satvik, it's not going to be 2 to 0. This is 2, this is 2. There is 1 carbon over here, right? This is 2 to 1. Right? It's not 2 to 0. Okay, they have mentioned 2 to 0, but it's 2 to 1. You can correct it on your own. What I told you, that was 2 to 1. What I wrote on the screen. Perfect? By mistake, they might have mentioned 0 over here. Okay, let's move on then. Let's try to give names to those compounds which have got functional groups attached, right? Which have got functional groups attached. Yeah? So first thing, I will try to make you understand like how to give the name to the compounds which contain the carboxylic acid as the functional group, right? One of the most important functional groups in your organic chemistry is the carboxylic acid, right? So let's try to name the compounds, right? Let's try to have a look on the rules which you need to follow in order to name the compounds which contains the carboxylic acid as the functional groups, right? Let's have a look now. Let's have a look. These are some basic things which I would want you guys to remember. And what are these basic things exactly? When carboxylic acid is used as the suffix, either its name is going to be oic acid. As a suffix, you write oic acid for the COH, or you write carboxylic acid. Either you write oic acid or carboxylic acid, depending on whether the carbon of the carboxylic acid is the part of the main chain or not. If the carbon of the carboxylic acid will be the part of main chain, will be the part of parent chain, main chain, then at that time, the suffix used is oic acid. The suffix used is oic acid. And if this particular carbon of the carboxylic acid is not the part of main chain, then what is the suffix you use? The suffix which you use is going to be directly carboxylic acid, right? We are talking about the functional group, which is C, double bond O, OH, right? This is the functional group which I'm talking about. If this carbon will be the part of the main chain, if this carbon is the part of main chain, then at that time the suffix used is oic acid. If this carbon is not the part of the main chain, then the suffix used is carboxylic acid, right? And if you have to use this COH as a prefix, at that point of time, you use carboxy. If you need to write prefix for carboxylic acid. These are 3 things which you need to remember. As a suffix, either oic acid or carboxylic acid. As a prefix, carboxy. Let me give the examples, and by solving the examples, every single thing will be clear to you, right? Oic acid, carboxylic acid, and carboxy. Let's try to name all of them. Okay, we'll be starting with the first example. This is basically C double bond OH. So over here there's a carboxylic acid which is as the functional group. right? So I'll be counting this carbon of carboxylic acid in the parent chain. I'll be starting the numbering from here. 1, 2, this is 3, this is 4. So 4 carbons means but, everywhere single bond. Butane. At carbon number 1, there is a functional group. Which one? This is carboxylic acid. Is the carbon of the carboxylic acid part of the parent chain? Yes, this is the part of parent chain. So the suffix used is oic acid. Right? This is going to be the name of the compound, butanoic acid. Yeah? Perfect, guys? It was supposed to be butane first, butane, right? But after this E, we are starting with the vowel. Perfect? So this E gets dropped. So it becomes butane, 1-oic acid. Yeah? Okay, look at this particular one. First thing, have a look. Is this carbon of the functional group the part of the main chain? Absolutely. 1, this is 2, this is 3, this is 4. At carbon number 2, you have got 2 methyl groups attached. So it's going to be 2, 2 dimethyl. 2, 2 dimethyl. In the main chain, how many carbon atoms you have? 4 carbon atoms. So the word root is going to be but. Everywhere it's a single bond. It's going to be N, right? And at carbon number 1, it's going to be oic acid. This is going to be the name. Perfect. If you look at this particular compound, guys, have a look. Let me start the numbering from here. From here or from here. The choice is all yours, right? Let me call this as 1, this is 2, this is 3, and this is 4. Perfect. Yeah. Now there are 2 carboxylic acids basically. This is 1 carboxylic acid, this is 1 more carboxylic acid, right? There are 2 carboxylic acids basically mentioned over here. Yeah. And both the carbons of the carboxylic acids are basically the part of parent chain. The carbons of the carboxylic acids are the part of main chain. So the suffix used is going to be oic acid, right? So 4 carbons, so it's going to be butane, right? Butane. Now at carbon number 1 and at carbon number 4, 1, 4, it's going to be what? It's going to be dioic acid. Dioic acid, right? Butane 1,4-dioic acid is going to be the name of the compound, right? Perfect, guys. Simple and basic at the same time. Let me take few more examples. Now look at this particular example, guys. Look at this particular example. So how many carboxylic acids you have? This is 1. This is 1 more. This is 1 more. So 3 carboxylic acids. Whenever in a compound you'll be having more than 2 carboxylic acids, none of the carbon of the carboxylic acid is to be taken into the parent chain. Whenever you'll be having more than 2 carboxylic acids, none of the carbon atoms of the carboxylic acids are to be taken in the parent chain. So let me start the numbering from here. This is 1, this is 2, this is 3. So all the carbons of the carboxylic acids, they are not the part of the main chain. So should I be using oic acid or carboxylic acid as the suffix? I'll be using carboxylic acid as the suffix, right? So I will be writing first of all, since there are 3 carbon atoms in the parent chain, it's going to be propane. Right? Then at 1, at 2, and at 3, this is going to be 1, 2, and 3, right? It's going to be tricarboxylic acid. Tricarboxylic acid. This is going to be the name of the compound, right? Perfect, guys. Look at the next one, my dear people. Let me start the numbering from here. 1, this is 2, this is 3, this is 4, this is 5, this is 6, right? So there are 3 carboxylic acids basically. None of the carbons of the carboxylic acid is to be taken in the parent chain, right? None of the carbon of the carboxylic acids over here is to be taken in the parent chain because there are more than 2 carboxylic acids in this chain over here. Yeah. Now have a look exactly. First thing, this is the cyclic ring. So I'll be using cyclohexane. Cyclohexane. At 1, 2, and 4. At 1, 2, and 4. There are 3 carboxylic acids, and none of the carbons of the carboxylic acids is the part of the main chain. So I'll be writing directly tricarboxylic acid. Tricarboxylic acid over here, right? I won't be using oic acid in this particular case. I'm sure it's clear to everyone. People, is it clear till here? Let me know fast. In the charts if it is super clear till here. Let me move on to a few more examples. Now have a look. These are few more examples related to the carboxylic acids. Look at this particular compound. It's a bicyclo compound, right? So before word root, you have to use bicyclo because you identified there are 2 carbon atoms in common. If it is the bicyclo compound, you are going to start the numbering from the rigid carbon, from here or from here. The choice is all yours, right? Now give the priority to what? Give the priority to the bigger sized ring. That means you need to give priority to, see, both the rings are same basically, right? 1, 2, 3, 4. 1, 2, 3, 4. Both the rings have got same number of carbon atoms, except these two rigid carbons, right? If both are same, but this one is substituted, right? This one is substituted. I'll prioritize this particular ring over here. So let me call this as carbon number 1. This will be 2. This will be 3. This will be 4. This will be 5. This is 6. This is 7. This is 8. This is 9. Now at the same time, what about the carbons of these carboxylic acids? Are these the part of the main chain? These two carbons of the carboxylic acids, these are not the part of the main chain. So the suffix used is going to be carboxylic acid, right? It's not going to be oic acid. It's going to be carboxylic acid. Perfect. Now first thing, I will be starting with something as bicyclo. First of all, it's going to be bicyclo, right? How many carbon atoms here? 1, 2, 3 and 4. Here, 1, 2, 3, 4. It's going to be 4, 4. In the middle, there is no carbon atom, right? 4, 4, 0. Perfect. Till here, everything is clear, right? Total, how many carbon atoms are there? There are total 10 carbon atoms actually, right? For carbon number 10, for 10 carbon atoms, what is the word root we use? We use dec, right? Then at 3 and 4, we have got 2 carboxylic acids. So I'll be writing 3, 4, 3, 4. Then I'll be writing dicarboxylic acid. Dicarboxylic acid. I won't be using oic acid over here, right? I'm sure this is clear. Perfect, guys. Now look at this special case. This is a particular case, right? Have a look exactly what it is all about. This is basically, over here there is CH2. This is basically CH2 over here. This is CH2. Then with CH2, COOH is attached, right? So let me start the numbering from here. 1, this is 2, this is 3, this is 4, this is 5, this is 6. Understand properly. Understand properly. First of all, these two carboxylic acids are directly attached with the main chain, whereas this carboxylic acid, it is not directly attached with the main chain. This carboxylic acid, it is attached with this carbon, and this carbon is then attached with the carbon, with the chain over here, right? Now, how am I going to name it? See guys, I hope you remember in the last session we have discussed such kind of complex substituents. Say, at carbon number 2, I'll be writing first of all carbon number 2, right? Then this is 1, okay? Then at carbon number 2, there is a substituent, right? In this substituent, at 1, there is what? There is COH. So COH over here is to be used as, this COH is to be used as prefix, right? And when COH, it is used as prefix, we use what? I'll be writing 1 carboxy. 1 carboxy. Then there is 1 carbon atom over here. It's going to be 1 carboxymethyl. 1 carboxymethyl, right? Then, in the main chain, how many carbon atoms are there? There are 6 carbon atoms. Is this cyclic? Absolutely. It's going to be cyclohexane. Cyclo, then I'll be writing over here, cyclohexane, right? Then at 1 and 2, there are 2 more carboxylic acids whose carbon is not the part of the carbon chain, right? Whose carbon is not the part of the main chain. So it's going to be, after hexane, I will be writing at 1, 4, at 1, 4, it's going to be dicarboxylic acid. Dicarboxylic acid. Let me know quickly in the chats if this one is clear. Right? This is the name. 2,1-carboxymethyl cyclohexane 1,4-dicarboxylic acid. If it is clear, let me know in the chats. Look at this particular compound. Is it the bicyclo or spiral compound? It's spiro basically, right? It's spiro because there is 1 carbon atom in common, right? 1 carbon atom is common. It is spiro. Perfect. Now people, in spiro compounds, how we used to start the numbering, if you remember. See, there are 2 rings basically. This ring, this particular ring, except this carbon. 1, 2, 3, right? This particular ring. 1, 2, 3, 4, right? This particular ring is the bigger sized ring. This one is the smaller sized ring. In the spiro compounds, we prioritize smaller sized ring first, if you remember. Let me call this as carbon number 1. This is 2. This is 3. This is 4, right? Let me call this as 5, 6, 7, and 8. Right? Now what is something which I'll be writing? I'll be writing spiro first of all. I'll be writing spiro. In the smaller sized ring, how many carbon atoms are there except this carbon? Except this particular carbon? 1, 2, and 3. 3 carbon atoms. Right? In the bigger sized one, 1, 2, 3, 4. Right? 3, 4. Spiro 3, 4. How many total carbon atoms are there? 8. So you'll be using oct. You'll be using oct. Is this COH? is the COH as the part of the main chain? I mean, its carbon is not the part of the main chain. Its carbon is not included in the main chain, right? So everywhere there's a single bond. So it's first of all going to be octane, right? And then at carbon number 6, you will be writing carboxylic acid. You won't be writing the oic acid, it's going to be carboxylic acid, because the carbon of this COH group is not the part of the main chain, right? Perfect, people? Yeah? Let me know fast in the chats if it is clear. Perfect, people? All right. So I'm sure all these things are clear to you properly. Yeah? I'm sure all these things are clear to you properly. Right? Quickly let me know in the chats if every single thing is clear. Let me know fast, people. Dina, let me tell you, the two carboxylic acids, right? They'll be used as the suffix, not the prefix, right? Okay, let's move on then. Now let's talk about those organic compounds which contains the cyanide group as the functional group, right? Let's talk about those organic compounds wherein the functional group is going to be cyanide. C triple bond N. Cyanide, again, one of the most important, I must say, right? One of the most important functional group, again, this is. The way we remembered certain names, like what to use as a prefix for cyanide, what to use as a suffix for cyanide, right? Those 2-3 names you are going to remember first of all. Let me first of all tell you, when this cyanide is taken as suffix, it has got 2 names, nitrile or carbonitrile. Nitrile is the suffix for CN, which we use when the carbon of this cyanide will be the part of the main chain. If the carbon of the cyanide is the part of main chain, then the suffix used is nitrile. If the carbon of this cyanide is not the part of main chain, then it's going to be carbonitrile. Nitrile when the carbon of cyanide is the part of main chain. Carbonitrile when the carbon of the cyanide is not the part of the main chain, right? And when as a prefix, you have to use cyano for it, right? These are 3 terminologies which you need to remember, basically. Rest all the rules are same. Nitrile, carbonitrile, cyano, right? Nitrile, carbonitrile, cyano. Okay, moving on. Let's try to give names of the compounds. These are few compounds which are given to us. Let's try to give names. Over here, you need to include this carbon of cyanide into the parent chain. It's going to be 1, this is going to be 2, this is going to be 3. So it's simply going to be 2-methyl. This is simply going to be 2-methyl, right? At carbon number 2, there was a methyl group. That's why I wrote 2-methyl. Then you have got 3 carbons in the main chain. It's going to be 2-methyl propane. Then this is the functional group at carbon number 1. Right? You will be writing nitrile. Okay, because the carbon of this cyanide is included in the main chain. Perfect? Yeah? Priya, tomorrow at 8 p.m. I'll be coming live. Look at this particular one. Start the numbering from here. 1, this is 2, this is 3, this is 4. At 3, there are 2 methyl groups. So 3, 3 dimethyl first of all. 3, 3 dimethyl. Then you have got 4 carbon atoms in the parent chain. Then I'll be writing butane. At carbon number 1, there is a basically cyanide group, right? So it's going to be 1 nitrile. Because why I'm using suffix as nitrile? Why it's not as carbonitrile? Because the carbon of this cyanide participates in the main chain. It is a part of the main chain basically, right? Look at this particular one. You'll be starting the numbering from here. 1, 2, 3, 4, 5, 6. Yeah? This carbon of cyanide is not the part of the main chain now, right? It's not included in the main chain. When the carbon of the cyanide is not included in the main chain, the suffix used is carbonitrile, right? So it's going to be first of all cyclohexane. Cyclohexane at 1, it's going to be carbonitrile. Perfect. I'm sure all this is clear. Right, people? I'm sure all this is clear. Cyclohexane 1, and this is going to be carbonitrile. Perfect. Let me move on and let's talk about the names of these particular compounds which I've come up with. See guys, look at this particular example. See, this is going to be your main ring. 1, 2, 3, 4 and 5, and this is 6, right? The carbons of these cyanides, these are not the part of the main chain. So what is the suffix I'll be using? Should I be using nitrile or carbonitrile? I'll be using carbonitrile, absolutely. So basically, it's going to be cyclohexane at 1 and 2, cyclohexane 1, 2, right? Is it going to be carbonitrile or dicarbonitrile? It's going to be dicarbonitrile because there are two CN groups over here attached. Yeah? Perfect. Again, you have got the bicyclo compound because there are two bridged carbons over here. This is the bicyclo compound. Perfect. Now, this ring contains some 1, 2, 3, 4 carbon atoms except these two. This ring again contains 1, 2, 3, 4 carbon atoms except these two bridged ones. So the choice is all yours. But this ring, it contains the two functional groups as well. So I will be giving priority to this particular ring. We always start the numbering from the bridged carbon. 1, this is 2, make it as 3, this is 4, 5, 6, 7, 8, 9 and 10, right? Apart from that, there are two functional groups which are attached. There are two cyanide groups which are attached basically, but none of the carbon of the cyanide groups is the part of the main chain. So what is the suffix which I'll be using? Should I be using as nitrile or carbonitrile? I'll be using carbonitrile because none of the carbon of two cyanides is basically participating, is taking part of the main chain. So first thing, I will be using bicyclo because it's a bicyclo compound. After bicyclo, how many carbon atoms here? 1, 2, 3, 4. How many here? 1, 2, 3, 4. How many in the middle? 0. So 4, 4, 0, right? 4, 4, 0, right? Then how many total carbon atoms? 10 carbon atoms. So I'll be using the term dec, right? Everywhere there's a single bond, decane, perfect. At 3 and 4, two functional groups. So 3, 4, right? Should I be writing carbonitrile or dicarbonitrile? It's going to be dicarbonitrile because there are two nitrile groups. This is going to be the name of the compound. Look at this particular one. Is it bicyclo or spiro? It's a spiro compound because there is one carbon atom in common between the two rings. Perfect. See, this particular ring, apart from the bridged carbon, apart from this particular carbon, 1, 2 and 3 carbon atoms. This particular one, 1, 2, 3, 4. In the spiro, we always give preference to the smaller sized ring. This is the smaller sized ring, right? This one contains only 3, yeah. 1, this is 2, this is 3, this is 4. Perfect. Now it's going to be your wish to give 5 to this carbon or give 5 to this carbon. That's going to be one of the same thing. This is 4. Let's call this as 5. Let's call this as 6, 7, 8. So first thing, I'll be using the term spiro. How many carbon atoms in the lesser membered ring? 1, 2, 3 carbons, right? How many over here? 1, 2, 3, 4. 4 carbons, 3, 4. How many total carbons in the main chain? 8 carbon atoms. So it's going to be oct. Everywhere there is a single bond, octane, right? At carbon number 6 and 7, there are two functional groups, right? CN. The carbon of this functional group is not the part of main chain. Even this is not the part of the main chain. So for both the ones, I'll be using the suffix as a carbonitrile. So it's going to be 6, 7. Now I'll be using dicarbonitrile. Dicarbonitrile. Perfect, guys. Let me know in the chats if it is clear till here so that I can move on. Let me know quickly in the chats if every single thing is clear till here. I'm sure it's supposed to be clear, right? Because everything is done and dusted. Perfecto, guys. Moving on. Let's give the name to this particular compound. Have a look. I'll be starting from this carbon. 1, this is 2, this is 3. Let's call this as 4, let's call this as 5, let's call this as 6, right? Now first thing guys, this is a complex substituent basically because we have got this side, this CN and this CN. They are directly attached with the main chain, but this particular CN, it's not directly attached with the main chain. It is attached with C, this CH2, and this CH2 is basically attached with the main chain. Perfect. So basically, this cyanide, I need to take it as the prefix. I will be taking this cyanide as a prefix, right? And these two will be directly taken as suffix, right? So basically, at carbon number 2, see what is going to be the name. At carbon number 2, right? At carbon number 2, then let me call this as carbon number 1 in this side chain, right? Then 1, okay? As a prefix, what do we call this as? Cyano, right? It's going to be cyano. cyano, one carbon over here, cyanomethyl, right? Cyanomethyl. Then we have got 6 carbon atoms in this particular chain. It's going to be cyclohexane, right? Then at carbon number 1 and carbon number 3, there are 2 CN groups, right? Then I'll be writing 1, 3, right? Since neither this carbon nor this carbon is the part of the main chain, so I'll be using carbonitrile. But should I be using just the carbonitrile or dicarbonitrile? I'll be using dicarbonitrile. I'm sure this is clear to everyone, right? Perfect, guys. Look at this particular example. This is again the bicyclo compound, right? Let me start the numbering from this Bridget carbon. Now both the rings, they contain the same number of carbon atoms, right? This ring, the right side one, this is substituted as well. So I'll be giving priority to this one. This is going to be 1, 2, this is 3, 4, 5, 6, 7, 8, 9. The carbon of this cyanide and carbon of this cyanide, they are not the part of the main chain. If they are not the part of the main chain, the suffix used is to be what? Carbonitrile, right? Not just the nitrile. Perfect. So how will I be naming it? I'll be first of all using the term bicyclo because it's a bicyclo compound. Perfect. 1, 2, 3, 4. 1, 2, 3, 4. It's going to be 4, 4. In the middle, there is no carbon atom joining between these two, right? It's going to be 4, 4, 0. Perfect. Then total carbon atoms. How many are there? There are 10 carbon atoms. So it's going to be dec. It's going to be dec. Everywhere is a single bond. Decane at, sorry, not the single bond. Sorry. Dec. At carbon number 3, it is basically the double bond, right? So dec at carbon number 3, it's going to be ene. At carbon number 3, it's going to be ene. Now after writing ene, at carbon number 3 and carbon number 4, at carbon number 3 and carbon number 4, I'm writing it over here, 3, 4, then I'll be writing dicarbonitrile. Dicarbonitrile, right? I'm sure you're getting all this. Perfect. This is going to be the name of the compound. Bicyclo 440 dec 3 ene 3, 4 dicarbonitrile. This is the name of the particular compound. Perfect, guys? Wonderful. Now, let's talk about those compounds. Let's talk about the compounds wherein the functional group is going to be aldehyde, right? Let's talk about the compounds wherein the functional group is going to be the aldehyde. Same the way we remembered 3 names for carboxylic and the way we remembered 3 names for the CN group. In the similar way, you're going to remember 3 names for this aldehyde group, right? Okay. When aldehyde is taken as suffix, it will be having 2 names. Either AL or carbaldehyde. L or carbaldehyde. L is used when the carbon of aldehyde group will be the part of main chain. If carbon of the aldehyde group is the part of main chain, then the suffix used is al, right? If the carbon of this CHO group is not the part of main chain, then you will be writing carbaldehyde, right? And if it is used as prefix, then I'll be using formyl, right? Then I'll be using formyl. These 3 things. Rest all the rules are same. Have a look now. Either al or carbaldehyde, and as a prefix, formyl. Al, carbaldehyde, formyl, right? Have a look now. Let's take this example. So over here, set is the functional group. This is the functional group. It is C double bond OH, right? This is the functional group basically, C double bond OH. This is what we call as aldehyde group, right? This is what we call as aldehyde group. So I'll be counting this carbon in the main chain 1, 2, 3, 4. So I'll be writing first of all but. It's going to be ane, and at carbon number 1, it's going to be L, right? I won't be writing butane because after E, there's a vowel starting, so I'll be dropping this E. So it's going to be butane 1L, right? Look at the next one, people. Let's call this as carbon number 1, this is 2, this is 3, this is 4. At carbon number 2, there are 2 methyl groups. So it's going to be 2, 2 dimethyl. 2, 2 dimethyl first of all. Then in the main chain, you have got 4 carbons. So you'll be using but, right? Everywhere there's a single bond. An at carbon number 1, there is the aldehyde, right? So suffix used is going to be L because the carbon of the aldehyde group is the part of the main chain, right, people? As simple as that. Look at this particular example. 1, 2, and this is 3, right? So first of all, you'll be using propane, right? Then first of all, you'll be using propane. And then at carbon number 1 and carbon number 3, 1, 3, it's going to be dial. Why I'm using dial? Because carbon of this and carbon of this both are the part of the main chain. So I'll be using al as the suffix over here. So this is going to be the name of the compound. Simple. Let me take 5 more examples. These are few more examples. Let's try to name them. Have a look exactly. This is simple, a cyclic compound wherein you have got CHO and CHO. Let's try to name it 1, 2, 3, 4, 5 and 6, right? So first of all, I will be writing cyclohexane. Cyclohexane. The carbon of this and carbon of this, both of the carbon atoms are not the part of the main chain. So I'll be using what? Carbaldehyde, not al as the suffix. I'll be using carbaldehyde as the suffix. Perfect. So it's going to be 1, 2 dicarbaldehyde. Dicarbaldehyde. Perfect. Right? Look at this particular compound. It is the bicyclo compound, right? Because we have got two bridged carbons over here. Now both the chains, both the rings, they contain the same number of carbon atoms, but I will be prioritizing this chain first because it's substituted. Let's call this as 1, let's call this as 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So first thing, I will be using bicyclo because it's a bicyclo compound, right? Then I'll be using 1, 2, 3, 4, 4, right? 1, 2, 3, 4, 4, in the middle 0, so it's going to be 4, 4, 0. Absolutely 4, 4, 0, right? Then how many total carbon atoms in the chain? 10 carbon atoms. It's going to be dec. Everywhere there's a single bond, so it's going to be decane, right? Decane. At carbon number 2, there is aldehyde, right? At carbon number 2, there is aldehyde, and carbon of this aldehyde is not the part of the main chain, so I'll be using carbaldehyde. So at carbon number 2, there is carbaldehyde. Got it? Perfect. Right, people? Same rules I'm following. Same rules I'm following. That's all. I'm nothing doing extra. This is first of all the Spiro example, right? This is the Spiro. Now people, this is one nice example. Have a look exactly. So first thing, you have got two rings. 1, 2, 3. 1, 2, 3, 4. Right? So I'll be starting the numbering from the lower membered ring. 1, 2, 3. This is going to be 4. Right? This is going to be 4. This is 5. This is 6. Right, people? This is 7. This is 8. Yeah? I'll give the numbering. Now first thing, have a look on this carbon number 7. Have a look on this carbon number 7. This CHO, it is not directly attached with the chain, but this CHO is directly attached with the chain. That CHO which is directly attached with the chain, I'll be considering it as a suffix, and this CHO, it will be definitely as a prefix. Now at carbon number 7 basically, at carbon number 7, its name will be slightly longer, at carbon number 7. At carbon number 7, let me call this as 1 again, right? At carbon number 7, this is going to be formyl methyl, right? Formyl methyl as a suffix. 1 formyl methyl. So this part is done. This part is done, right? Then simple, the same way we are going to use, it's going to be a Spiro compound. It is Spiro, right? In this, how many carbons? 3. Over here, 1, 2, 3, 4. So 3, 4. Lower to higher, 3, 4, right? How many total carbon atoms do we have over here? 7. So it's going to be hept. It's going to be hept. Everywhere there is a single bond, it's going to be heptane, right? At carbon number 6, there is aldehyde, and carbon of this aldehyde is not participating, it's not the part of the main chain. So I'll be using at carbon number 6, it is carbaldehyde. Carbaldehyde I have used as the suffix over here. I'm sure it is clear to everyone. Yeah? Let me know in the chats if it is clear, people. So I'm sure all these examples are clear. Okay, this is one more example. This is one more example, and in this particular example, you have got two functional groups. This is carboxylic acid, this is aldehyde. Carboxylic acid, aldehyde. Let me tell you, priority among the two is given to carboxylic acid. I will have to give priority to the carboxylic acid first. So this carboxylic acid, it should get the least number in the parent chain, right? So I'll be starting numbering from here. 1, 2, this is going to be 3, 4, 5, and 6, right? So this is the major functional group over here, right? I will have to consider this as the prefix, and when it is considered as the prefix, we have to use formal as the prefix. So at carbon number 3, I will be using formal, right? Formyl, right? It's formyl. At carbon number 3, it's formyl. Perfect. Now you'll be simply writing cyclohexane, 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 right? Is the carbon of carboxylic acid the part of the main chain? No way. When carbon of the carboxylic acid is not the part of the main chain, then the suffix used is not oic acid, it's the carboxylic acid. And at carbon number 1, I will be writing carboxylic acid. right? Carboxylic acid. Perfect, guys. Every single thing clear? Every single thing is clear? Yeah? Now there are compounds which contain the functional group as amide, but this amide, CONH2, is something which I'll be letting you know in the next session, right? So in the next session, this IUPAC nomenclature is going to get completely covered, right? In the next session, this whole IUPAC nomenclature will be done and dusted. And people, at the same time, if you have not enrolled in the NEET 2022 crash course, do get enrolled in it as soon as possible, right? The details already I've told you. There will be 120 plus live sessions, right? With the online live interaction. Okay, you can ask your doubts anytime to your master teachers, right? Test series, no need to worry about. Test series is provided in this particular crash course only. Yes, I'm at Kashmir right now. Yes, absolutely. Okay, and people, chapter-wise assignments will be there by means of which you can compare your ranks with other students across the country, summary notes, right? Formula revisions, class recordings, right? And these are the number of sessions which are allotted to different topics, different chapters of your physics, right? These are the number of sessions which are allotted to different chapters of your chemistry. Basically, in just one single session, the whole chapter will be done, starting from the basics, and all the problem patterns will be done in that particular session only. And after the session, you'll be getting the the PDFs of the session, class notes, handwritten class notes. Apart from that, assignments which you need to solve, which you need to submit to. Right after the submission, you'll be getting the results of those assignments as well. And eventually, you can compare your ranks with the other students sitting across the country, right? Okay, so these are the number of sessions which are allotted to chemistry. Then comes your botany, right? These are the number of sessions allotted to botany and zoology at the same time. And if you want to meet your teachers who are going to teach you in this class, in this NEET 2022 crash course batch, Rajni ma'am will be taking care of your biology, and with her, Ambika ma'am taking care of the biology. Then you have got Disha ma'am taking care of chemistry. You have got Rahul sir again taking care of physics. He's the alumni of IIT Kharagpur, basically has got the teaching experience of more than 5 years, produced hundreds of top all India ranks. You guys are absolutely going to love it, people, if you join this particular crash course batch. And this particular crash course, NEET 2022 crash course batch, what else you are getting apart from the crash course? Apart from the crash course, you will be getting the class 11th complete recordings from all the subjects. That too, you will be getting access to these recordings for one complete year, basically, right? Okay, apart from the crash course, if you are, for example, the NEET 2023 aspirant, you will be getting the class 11th complete recordings for physics, for chemistry, for biology, that too for 1 year complete, okay? Right? And the cost of this batch, it's affordable, 9K. If you will be using this coupon code WSCC, link is there in the description box of the video. So my personal suggestion for you guys to get enrolled into the crash course, right? It's going to be highly beneficial for all of you, right? How to get enrolled in this particular batch, people? See, this is the video which you guys are currently watching, right? Just drag the video a little down. Just drag it a little down. Click on show more. After clicking on show more, you need to click on NEET 2022 crash course. Click on it. Once you click on it, you need to drag it a little down. And once you drag it a little down, you need to click on buy now. After clicking on buy now, you'll be putting your number, your email ID on which you'll be getting the OTP and everything. And eventually you'll be getting enrolled into the NEET 2022 crash course batch, which is the best and the last option for you guys to score up. To shoot up your ranks in the NEET 2022 examination. So do get enrolled into as soon as possible. It is, trust me, beneficial for all of you, okay? So at the same time, few minutes back only, like 1 hour back or 1.5 hours back, I uploaded one video on this particular channel. Do check that out, right? Because tomorrow I'm going to take a session in which you are going to get one biggest surprise, right? Particularly for the ones who are going to write the NEET in 2022. One big surprise which absolutely all of you are going to love, right? So do catch me up tomorrow at 8 PM on this particular channel, and tonight also you can catch me up on Vedantu JE English channel sharp at 9:30, right? On 9:30 tonight you can watch me again on 9:30 on Vedantu JE English channel, wherein I will be doing the most expected questions from the chapter chemical bonding, right? Okay, so basically I'll come up with around 50 questions from the chapter chemical bonding. So I'll be solving those questions. If you want to master chemical bonding chapter in the form of questions, do join me tonight sharp at 9:30 on Vedantu JE English channel. Till then, you take care, bye-bye, God bless you all and love you all. And soon I'll be coming up with the one more session of this IUPAC nomenclature, which is going to be the third and the last session of this IUPAC part, right? Perfect. So take care, God bless you, love you all.